Welcome back. This is Randy. I'm back in the shop today and I'm working on the Dart small block Chevy build, the one that's 357 cubic inches, and it's got the Brodex 18-degree heads, and I'm going to be working on the cutting the valve seats and stuff on this one head, and I'll bring you over to the head that I had fixed over at Brodex. This here is the head that I had fixed at Brodex. This is the chamber that they fixed, and this whole area here in between the valve seats was all blown out, and the valve seats were gone because the motor had dropped the valve. And I sent pictures to Brodex and to see if they could repair it, and they said they could, so I sent them the head, and it come back and it's just like brand new. What I did is I CC'd the chamber here on this head, because this head has been cut 10 thousandths and it measures 43 cc, and on the old head over here the chambers measured 45 and a half. So what I did is I surfaced this head 10 thousandths, and now I'm going to cut the seats in here. I'm going to get this other head set up here a second. I'm going to explain something to you, and I'll be right back. All right, what I got here is I got two of the old valves here, and I put them in the lathe, and I center drilled them, and I put a ball in the top, in the center. And what I'm doing here with this bridge with the dial indicator on it is I'm measuring the height of the valve seat, of the valve itself, and I have to match the height on the other head because those seats have not been ground yet. So I take this and put this on the other head here. I'm going to set this down. Grab this valve, and we slide this in here like that there, and and we take this bridge here and we set this on here, and we slide across it like this here. And that's showing me that these valves are up this way 15 thousandths, about 16 thousandths actually, more than what's in the other head. And the reason that's critical is because your piston to valve clearance, you need roughly 100 thousandths on the exhaust and about 100 thousandths on the intake. You can get away a little bit with a little bit less on the exhaust, but on the intake that's real critical, because as the intake valve is opening, I'm trying to think here, no, I got that wrong. It's on the exhaust it's more critical, because on the exhaust, as the exhaust valve is opening, the piston is actually coming up still in the bore to help push the exhaust out. And you need to maintain that piston to valve clearance for high RPM, in case you get some valve bounce and whatnot, so you don't contact the valve with the piston. But that's how you measure that there. It's let's see if I can show you a little better here. See if you can see that. It's showing 16 thousandths difference, and they're all just a little bit different. So what I've got to do is I got to grind each seat and check the height on them. That way they're all the same. So I'll get this one done here, and I will bring you back in just a few minutes. All right, I got this ready to go here, and somebody in one of the other videos had commented about the fact that to not let this motor hang on the pilot, and I was trying to explain to him that this handle here, you can position this anywhere you want just by loosening it up. Then you tighten it, and the handle itself, I don't know if you'll be able to see that, is marked, and you put pressure on it like that there. It's marked V8 right here, and it's got 6-cylinder and stuff on it. So you push this up. When you put tension on it like that there, you're actually floating this grinder head on the pilot so that it cuts the seat concentric. And I'm going to go ahead and cut this one, and we'll see how it looks. Pull that out there. This is how it looks after I get done grinding it. And this is the 45-degree angle. And what I'll have to do is narrow this seat up, because this 45-degree seat part here is actually too wide. So I'll come in with a 30-degree top stone to narrow that up, and then I'll hit it really lightly with a 70-degree on the bottom, and then we'll recheck the height on the valve. After I get done doing that, I'll be right back. All right, the intake seat here on the second head, I've got that all cut in. As you can see, it's reading 0, which is the same as the valve height on the other head. And now I have to go through and finish all the rest of the other 3 intakes, and I have to do the same process on the exhaust to make sure that the valves are all the same. Let's see if I can pop this out of here a second. And this seat has been all the 30-degree on the top, the 60-degree on the bottom, and the 45-degree. The 45-degree, you can see where I lapped it to make, and it's making good contact with the valve face all the way around. And so this one here is done. Here's the valve right here. You can see the seat, the 45-degree on the valve. You can see how that's contacting there. That's all sealing good. And got 3 more intakes to do, and then do all the exhausts, and then this head, that portion of it will be done. And I got a couple little nicks here from where trash had gone through the motor from when it dropped the valve. I gotta just emery roll that a little bit just to kind of blend that in. And then when I get this done, I'll re-see a chamber here to see if it's close to the other head, which it should be, because you need to remove 7/1000 of material and 7/1000 while you'll decrease the chamber size 1 cc. So I took 10 off of this head to match the other head, which should bring it pretty close. Anyway, I'll bring you back when I'm done. All right, I got the valve seats all cut, and got the plate put on the top here, and got a spark plug in it, 2 valves in it, and I CC'd chamber, and the chamber came out to just a little over 44 cc's, like 44.3, and the other chamber was 44, so that's pretty close. And now the next item on the agenda to do is to put a couple rods on the pistons and install them in a block, and I need to clay the valve reliefs and degree the cam and whatnot, and assemble the rocker arms and stuff, and check it for piston to valve clearance. And the reason I'm claying the valve relief is to check for radial clearance. I got to have at least 60 thousandths radial clearance on the back side of the valve relief to to be sure that I've got enough clearance. Let me grab a piston here, and an old piston here, and I'll show you what I'm talking about. This is an old piston right here, and by radial clearance, what I'm meaning is the clearance on the back side of the valve relief here. Because these valves at high RPM, that stuff is all moving. The top of the valve stem is going all crazy. The head is moving around and everything. And you don't want to have the valve hit the piston on the back side here. So that's why I've got to assemble it, mock it up, and check it for that clearance. And if I don't have enough clearance, then I need to get my piston vise out and put it on a mill, and I need to mill that out slightly. But chances are it's okay, but if you don't check it, you don't know. And at 82 or 8300 RPM, why you don't, things go bad in a hurry. So you got to give yourself all the chance you can. And this is just one of the steps that you got to go through doing these types of motors. So hope you enjoyed that. And when I get to that point, why, I'll bring you along and we'll check it and we'll see where it is, and we'll go from there. So anyway, thanks for watching. Hope you had a great day, and we'll talk to you later. Bye-bye.